Let's partition a segment. So consider this problem. Partition the segment connecting A at -5, 2 with B at 6, -3 with some point P. A to P and P to B need to be in a 5-to-1 ratio. So that's the situation. So we have a segment from A to B, and we want to partition it with a point P. We're going to place a point P somewhere on that line segment so that A to P is in a 5-to-1 ratio. Let me draw a picture of that and show you what that looks like. So what I would do is I would actually plot point A and point B, and then I would place this using my common sense. Now, this is going to be the final answer, but let's pretend like we don't know that. I would place the point P about there so that this distance is in about 5 times longer than this distance, because the problem says that A to P and P to B need to be in a 5-to-1 ratio. And so I would approximate that it's going to be about right there. Now, it just so happens my answer was incredibly accurate, but you can just eyeball this and kind of tell where it's going to be. Now, the benefit of drawing this sketch is if your answer is way off, like if your point is not even on the line or it's not in a 5-to-1 ratio, then you'll know something's wrong and you can go back and kind of correct the error. So that's what I would do first, kind of sketch it. Pretend like you don't know this answer yet. That is going to be the answer, but let's pretend like we don't know that yet. And we're going to find it. So what we do, the very first thing that you want to do with this, besides drawing the sketch, so that's the first thing, draw that sketch. The next thing you want to do is take care of this 5-to-1 ratio to find the fraction you're going to be using. So a 5-to-1 ratio means we're going to use 5, the first number, over the sum of 5 and 1, which ends up being 6. So we're going to use this fraction 5 over 6. So the numerator is the first number in the ratio, and the denominator is the sum of those two together. So 5 over 6, that's what we're going to be using. The next thing, so we draw the sketch, and then we find this fraction. The next thing we're going to do is find the slope. So the slope between the 2 points, those 2 points, let me show you how you can do that right here. So given these 2 points, we're going to find the slope. Now you can either do y sub 1 minus y sub 2 and put that on top, and x sub 1 minus x sub 2 and put that on the bottom. You can do that and you get this. Notice you get 5 over -11, but the negative always goes with the top number when you only have a negative on the bottom. Now, if they were both negative, you would make the result positive, right? It's like if it had been -5 over -11, I would have put positive 5 over 11. So you need to know some of these basic things. I mean, if you're having trouble with integer multiplication and division, then you have bigger problems than this particular problem. You need to go back and find a video on that. But anyway, hopefully you understand why I didn't go with this and I went with this. The negative goes with the top number. So this is what I write. But alternatively, I could have started over here with y sub 2 and done minus y sub 1, and then I would have needed to come over here. So you can do it either way. It doesn't matter which point you start from, because a lot of times students are like, well, which one do I start with? Well, it doesn't matter as long as you're consistent. So if I start over here with the y's and go that way, I need to start over here with the x's and go that way. And the other way around, if I start over here with the y's and do this minus this, then on the bottom, I better do this minus that. So you're consistent. Anyway, I just wanted to show you that you get -5 over 11 either way, because 6 minus -5 ends up being a positive 11. So this way you don't have to adjust the subtraction or the negative sign. This way you did, but you end up with the same thing. So you draw the sketch, you find the fraction with the ratio, and then you find the slope. And then what you're going to do, the final part that you do, is you take the x value on the first point. So the x value on the A point is -5, and you're going to add to that your fraction times your X value on your slope, the bottom number on your slope, okay? So -5 was the X value on A, and I'm going to add to that 5, 6, which is my ratio, times this X value on your slope. And if you do this on a calculator, you're going to get about 4.16. Now let me show you what that looks like on the calculator, because I want you to be able to do this. You can, of course, you can do it without a calculator if you're a pretty good math student, but if you can't, this is what you want to type in. So I'm typing in -5. Look at how I'm doing this. Plus, and I'm going to use these parentheses here. So parentheses 5 divided by 6. So parentheses 5 divided by 6. There's parentheses on here. So 5 divided by 6. And then times 11. And when I hit equals, that's what I get. So that's why I have this here, 4.16 repeating. So that's going to be the X value. Now I'm going to clear that out. And the next thing I want to do is I want to take the Y value on the A point and add 5, 6 times the slope number on the top, the Y value on the top. So I multiply 5, 6 times -5 because that -5 up there. And look at how I would do that. I would go 2 plus, and in parentheses, 5 divided by 6. I'm putting that in parentheses so that it's treating it as one number. So 5, 6 times, and it's times -5. See that times -5. So I want to put that in parentheses too, just to be careful. So I did 2 plus 5, 6 in parentheses times -5. Now when I do that, I get -2.16 repeating. So that's where that comes from. So then the very last step is to write that answer down. So you would write it as an ordered pair. Here it is. As an ordered pair. There's my X value, there's my Y value. And notice I'm verifying that this is about over 4 and down -2. So this is a very accurate drawing, even though I just approximated it. But this is my final answer. Now the ones I've seen in geometry textbooks use decimals, but if they didn't use decimals, we would just leave it as in fraction form. But the ones I have seen have decimal answers, so I think that's going to be just fine. I kind of like decimals in an application problem anyway, because I think 4.16 makes a whole lot more sense than, like some fraction that I might not know exactly where it is. Like if I had 28 over 7 or 28 over 7.1, I'd end, or 28 sevenths or 28/6, something like that. If you reduce it, that's a fraction that might not be as meaningful as a decimal. So personally, I like the decimal answers. I think the book's right in accepting those decimal answers. So that's it. So A to P and P to B are in a 5-to-1 ratio. This is 5 times bigger than that. So this is my answer, and this is how you partition a segment. So if you have questions, feel free to comment. If you have a question you want me to solve on video, leave that as well. See you later.